Hey guys, this is Mr. Anziano again. This is pretty much a direct pickup to yesterday's video, and I'm recording this at 5 a.m., so forgive me if I make any mental errors this early in the morning. So here it is, guys. We've got example 3 for 1.3 notes. This is what you're going to watch today in class, in addition to last night's video if you didn't have a chance to watch that. And it's actually pretty quick and easy and painless. So let's take a look at 1.3 Objective 3. This is the page right before the last page where you're going to be doing some practice. Alright, so first question we have is, which variable, x or y, does the function notation f of x represent? And we've been saying for the last few years that f of x is synonymous with y. Right? So if you have f of x, really you're just talking about the output or the y value. Now if f of x is equal to 0 for a given point on the graph, then where is that point located? If the y value is 0, then you know that you are right on the x-axis. If the output f of x is greater than 0 for a given point on a graph, then where is that point located? Well, it's simply going to be above the x-axis. And of course, if the above is true, then when the output f of x is less than 0 for a point on the graph, then that point is below the x-axis. So the goal here is to kind of get a sense of how being on the x-axis, above the x-axis, or below the x-axis is similar and yet different from intervals that are increasing, decreasing, and constant, which is why we're looking at these back-to-back. So our first task here is to figure out when the output is exactly equal to 0. And of course, we may have one point, we may have a set of points, or we may have some intervals to consider. So let's see what the situation is. We are exactly on the x-axis when x is -3, when x is 0, and when x is 6. So our solution is simply x equals -3, 0, and 6. Okay, not really a different way to write that using our fancy notation that we just learned yesterday or just a moment ago. We just have 3 values. The function output is greater than 0 now for any values on the function that are above the x-axis, right? So we just need to look and find when exactly is my graph above the x-axis, and it starts there at -3. We go up, and hey, we're increasing on this interval here, right? But we are greater than 0 on the interval that ends right there at 0, because we can't really say with 100% certainty what's happening at 0. In fact, we know from before that at 0, aren't we on the x-axis and no longer above it? So really that means that we have the interval using open interval notation, -3 to 0, but also we are still above the x-axis on the interval starting back at 0, but not including 0, and ending at 6. Okay, so we use our union notation, the interval -3 to 0, union or 0 to 6, the open interval. Guys, we can also write this using inequality notation, so I encourage you to, I'm going to pause for a second, and I want you to kind of fill these blanks in. Inequality notation would look like one blank that you need to fill in there and another blank, and we would read it as some interval using inequality notation or another interval using inequality notation, and those come directly from our given intervals. So take a second, see if you can fill that in. You can pause if you need to. Here it is. We're on the interval -3 is less than x is less than 0, or in other words, x is between -3 and 0, or x is between 0 and 6. Alright, so there's inequality notation and how it compares to interval notation. Alright, and finally we need to figure out when the output is going to be less than 0. So we have, what's the situation right here at -5? Do we know that this thing is going to continue going on forever? Do we need to? All we do know is that at -5, my function is definitely below the x-axis, so I can use a closed bracket there to indicate that -5 itself is in fact less than the x-axis, or less than 0. However, at -3, we need to go back to our open interval or parenthesis notation because at -3, we're on the x-axis. And finally, at 6, we are also on the x-axis, but beyond 6 and up to 7 with a closed bracket, we are below the x-axis. So my intervals should look like close bracket, -5 to -3 with a parenthesis union the open interval starting at 6 and ending at the closed interval 7. All right. Now again, this can be done using inequality notation. Maybe pause the video and try and fill it in yourself. It's going to look like that or that. All right. And that should look like x is between, but with a inclusion symbol here, less than or equal to, less than on this side, or x is between excluding the first value, but including the final value. So my numbers are -5 here, -3 there, or 6 here to 7 there. So x is between -5 and -3, including -5, excluding -3, or x is between 6 and 7, excluding 6, but including 7. All right. Now, my last couple questions are here. Identify the domain of the graph function. This is where I got cut off in my previous video, but we've got plenty of time now. The domain, guys, is simply where the graph is covered on the x values. So in other words, the domain of this function, we know that all of the x values throughout the entire thing are hit or covered by a y value. They all correspond with a y value on the graph. There are no holes, in other words. There are no discontinuities. So the domain is simply all of the x values that you see on this graph. So we go from -5 to 7. And that's going to be a closed interval because we are including both of those points in the domain. So -5 to 7 is the domain of the function. Similarly, the range just means that we need to look at all of the y values being covered. So we actually start down here at my minimum point, y value, I should say, of -4, and we go all the way up to a maximum of +4. All right, and that's domain and range. Not too bad, right? All right, guys, so your task for today, before we take a little quiz for the last portion of our Friday, is to look at the 1.3 practice, try and get ahead so you don't have to do too much for homework. It's going to start out a lot like what we did yesterday during class. And in fact, looks like that's about it. So you've got to do some function value evaluation and figure out what the various outputs are at certain inputs, and then multiply, add, subtract, divide. So operations on functions. That's what we're doing. All right, guys. Hope that was all clear. If you have any questions, shoot me an email. I will be back on Monday. Have a great weekend.